All right, so you really went all out with this database deep dive request.
Yes, you weren't kidding.
Notes, articles, even a whole chapter from a computer science textbook, huh? Looks like someone's serious about getting up to speed.
It's quite the collection, but it shows a real desire to understand not just the what, but the why of databases. That's where the real understanding kicks in.
Exactly. And we've even got some code snippets in here, too. Where should we even begin?
Well, your notes start with the very basics, defining data as raw, unprocessed facts.
Okay.
Imagine a massive online retailer, for example.
Right?
They're collecting mountains of data every second, customer purchases, website clicks, product reviews.
Right.
In that raw state, it's just noise. But a database management system, a DBMS, can turn it into gold.
So the DBMS is the key player here. It's not just storing data, it's making sense of it.
Exactly. A DBMS can identify popular products, predict future trends, even personalize recommendations for shoppers. That transformation from raw data to actionable insights, that's at the heart of what a DBMS does.
That's a huge leap from what I thought a database was. I was picturing something like, a giant spreadsheet. But it sounds a lot more dynamic than that.
Spreadsheets are definitely part of the database world, particularly when we talk about relational databases. But your textbook also mentions hierarchical and network models. These different models offer ways to structure how data points connect to each other. It's like choosing the right organizational system for a library.
Okay, give me a real-world example of that. How would these different models play out in practice?
Okay, well, imagine you're building a family tree.
Right.
The hierarchical model is a natural fit, parents at the top, branching down to children, and so on. But let's say you're mapping relationships in a social network where connections are much messier. That's where a network model shines, because it can handle many-to-many relationships.
And for data that fits neatly into rows and columns, like customer orders or inventory lists, that's where the relational model comes in. It's like the classic library card catalog, with each entry having its own designated fields.
Precisely. And within those tables, we need a way to uniquely identify each record. That's where database keys come in. Your notes specifically mention primary, candidate, and alternative keys. It's like having a system to ensure no two books in a library have the exact same call number.
So the primary key is like the main identifier, the one you'd always use to find a specific record.
Exactly. And you have some flexibility in choosing this primary key. Candidate keys are any attributes that could be unique identifiers, like a student ID or a driver's license number. But only one gets chosen as the primary key, while the others become alternative keys.
That makes sense. But why bother having alternative keys if you've already got the primary one?
It's about having options and ensuring data integrity. Imagine a situation where a student loses their ID card. If the email address was set up as an alternative key, you could still uniquely identify that student's record.
Okay, that's helpful. It's like having backup identifiers in case the main one goes missing. So we've got our data organized, each record uniquely identifiable. What's next?
Well, now we need a way to actually work with that data. Add new records, modify existing ones, retrieve specific information. That's where database languages come in. Your textbook focuses on data definition language, DDL, and data manipulation language, DML.
DDL and DML sounds a bit like alphabet soup.
Think of DDL as the language for constructing the database itself. It's like the architect's blueprint, defining the tables, the data types for each field, the relationships between them. Commands like create, alter, and drop fall under DDL. You're setting the whole structure up.
And DML is for actually interacting with the data within that structure.
Exactly. DML is all about manipulating the data, inserting new records, updating existing ones, deleting those no longer needed. Commands like select, insert, update, and delete are your bread and butter here.
So it's like DDL builds the library, and DML is how you check out books, return them, maybe even request new ones to be added to the collection.
That's a great analogy. And to make sure that library is running efficiently, we have normalization. Your notes describe it as minimizing redundancy and inconsistency.
So no duplicate copies of the same book taking up shelf space and making sure all the information about a book is stored in the right place.
Exactly. Normalization involves breaking down data into smaller, well-defined tables. It makes the database more efficient and easier to update. Your textbook uses the example of storing recipes on index cards. With normalization, you'd have separate cards for ingredients, instructions, and nutritional information.
That makes sense. If you wanted to update a recipe, you wouldn't want to have to change it in multiple places throughout your database. It'd be a nightmare to keep track of.
Exactly. And speaking of keeping track of things, where we actually store all this organized data is another key consideration. Your research mentions centralized and distributed databases.
Okay, so we're talking about different ways to physically house all this information.
Precisely. Think of a centralized database like having all your recipes stored in one physical cookbook.
Okay.
It's simple, easy to manage. But what if that cookbook gets lost or damaged? A distributed database is like having copies of those recipes spread across multiple devices. Even if one fails, you haven't lost everything.
So it's like a backup system. But it's also about accessibility, right? If you've got multiple people who need to access the database, it's more efficient to have it distributed across different locations.
You've hit the nail on the head. Centralized databases work well for smaller operations, but as the volume of data and the number of users grow, distributed systems become more appealing. It's like having multiple kitchens in a large restaurant, each with access to the recipes they need.
That makes sense. Now, regardless of where we choose to store our data, one thing that keeps coming up in your research is the importance of security. It seems like we're finally getting to that vault you mentioned earlier. What are the main things to consider when it comes to database security?
Well, your notes highlight several key aspects: authentication, authorization, encryption, auditing, and monitoring. It's a multi-layered approach, like having multiple locks on a door to protect something valuable.
All right, break that down for me. What do each of those security layers actually do?
Well, think of authentication as verifying someone's identity before they can even approach the database. It's like a digital ID check at the door.
Okay.
Authorization then determines what they're allowed to do once inside. Can they only read data, or can they also modify it? It's like having different levels of access within a library. Some people can only browse, while others have borrowing privileges.
So it's not just about keeping unauthorized people out. It's about making sure even authorized users can't access things they shouldn't.
Precisely. And then we have encryption. This scrambles the data, making it unreadable to anyone without the decryption key. It's like having those secret recipes written in code that only authorized chefs can decipher.
That's a great way to put it. So even if someone manages to break in, they can't make sense of the information without the key. What about auditing and monitoring? What role do they play in database security?
Think of auditing as keeping a detailed log of who accessed what data, when, and what changes they made. It's like having security cameras recording all activity within the library. Monitoring then involves actively analyzing those logs to detect any suspicious patterns or potential breaches.
So it's like having a security guard reviewing the footage, looking for anyone acting suspiciously or trying to access restricted areas. It sounds like a lot of work to keep a database secure. Your research does mention a whole bunch of potential threats as well. Why is database security such a big deal for organizations in particular?
Well, your source material makes a strong case for its importance. It goes beyond just protecting sensitive information. It's about compliance with regulations, preventing data breaches, maintaining data integrity, ensuring business continuity, protecting intellectual property, maintaining customer trust, mitigating financial losses, and even preventing insider threats.
Wow, that's quite the list. Let's unpack some of those. Why is compliance with regulations so crucial when it comes to databases?
Organizations today operate within a web of data protection laws and industry standards. Think GDPR, IPR, PCI DFS. They set strict rules for how data should be handled. Non-compliance can lead to hefty fines, legal battles, and a tarnished reputation.
It's like having a health inspector come into a restaurant. You need to meet those standards to operate legally and maintain the trust of your customers. What about data breaches? We hear about those all the time in the news. How much of a risk are they really?
Data breaches are a constant threat, and they can be devastating for organizations. Imagine a retailer losing millions of customer credit card numbers, the financial fallout, the legal repercussions, the damage to their brand. It could take years to recover.
It's like having your entire recipe book stolen, including all your secret ingredients and techniques. Your competitors would have a field day, and your customers would never trust you again.
Exactly. That's why organizations need to implement multi-layered security measures, including strong authentication, network security, encryption, and regular audits. It's about being proactive, not reactive, when it comes to data protection.
So it's not just about fixing problems after they occur, it's about preventing them in the first place. What about maintaining data integrity? Why is that so crucial in an organizational context?
Data integrity is about ensuring that data remains accurate, consistent, and reliable throughout its life cycle. Think of a financial institution relying on corrupted data to make lending decisions. The consequences could be disastrous.
It's like using a recipe with incorrect measurements or spoiled ingredients. The dish won't turn out right, and you might even end up getting sick.
Exactly. Data integrity is essential for making informed decisions, maintaining accurate records, and ensuring the reliability of research findings. Organizations need to implement data validation rules, conduct regular quality checks, and have audit trails to track any changes made to the data. It's about having confidence in the information that drives their operations.
And what about business continuity? Why is database security so crucial for keeping things running smoothly?
Today's organizations rely heavily on their data systems to function. Any disruption, whether caused by a natural disaster, a cyber attack, or even a simple power outage, can have a ripple effect. Imagine a manufacturing plant losing access to its production data. Everything would grind to a halt.
It's like having a blackout in the middle of a busy service in a restaurant. You can't take orders, you can't prepare food, you can't even process payments. It would be chaos.
Exactly. That's why robust disaster recovery plans are essential. Backups need to be regularly tested, systems need to be redundant, and there needs to be a clear process for restoring operations as quickly as possible. It's about minimizing downtime and ensuring that the business can keep running even in the face of unexpected events.
So it's like having a backup generator for the restaurant, or maybe even a second kitchen ready to go in case the first one becomes unusable. What about intellectual property? How does database security play a role in protecting those valuable assets?
Think of a company that's invested millions in developing a groundbreaking new product. The designs, the formulas, the research data, all of that might be stored in databases. Protecting that information from theft or unauthorized disclosure is paramount to their success.
It's like having a secret recipe that gives your restaurant a unique edge. You wouldn't want that recipe falling into the hands of a competitor, would you?
Absolutely not. That's why organizations need to implement strong access controls, encryption, and data lock prevention technologies. It's about treating intellectual property as a crown jewel that deserves the highest level of protection.
Right, it's like having a vault within the vault, with multiple layers of security to keep those most valuable assets safe. Now, you mentioned customer trust as another key reason why database security matters. Why is that so crucial in today's business landscape?
Customers entrust organizations with a vast amount of personal information, from contact details and purchase history to financial data and even sensitive health records. That data needs to be treated with the utmost care. A breach of that trust can have devastating consequences.
It's like customers sharing their family recipes with a restaurant, expecting them to be used responsibly and kept confidential. If those recipes were leaked or misused, the trust would be broken and the damage would be hard to repair.
Exactly. Building and maintaining customer trust is paramount in today's data-driven world. Organizations need to be transparent about their data practices, implement strong security measures, and respond swiftly and responsibly to any incidents that may occur.
So it's not just about protecting the data itself, it's about protecting the relationships with the people who have entrusted you with that data. Speaking of consequences, you also mentioned mitigating financial losses as a key benefit of strong database security. How exactly does that play out?
Data breaches and security incidents can be incredibly costly. Think fines, legal fees, lost revenue, remediation expenses. The financial impact can be significant and long-lasting.
It's like having a fire break out in a restaurant. You've got damage to the building, lost inventory, disrupted operations. The costs can quickly add up.
Exactly. And just like fire prevention measures are essential in a restaurant, proactive security measures are crucial for organizations. Investing in strong security practices is not just about compliance, it's about protecting the bottom line.
So it's like having insurance for your data. You hope you never have to use it, but you're prepared in case something goes wrong. Now, we've talked about external threats, but you also mentioned the importance of preventing insider threats. What makes those so challenging to address?
Insider threats can be tricky because they involve individuals who already have authorized access to systems and data. Think disgruntled employees, careless contractors, or even well-intentioned staff who accidentally make mistakes.
It's like having someone in the restaurant who knows where the keys are kept, understands the security system, and can move around freely without raising suspicion.
Exactly. That's why organizations need to implement measures like role-based access controls, activity monitoring, background checks, and security awareness training for all personnel. It's about creating a culture of security where everyone understands the importance of protecting data and is vigilant about potential threats.
So it's not just about technology, it's about people. It's about building a team that's committed to protecting data and understands the risks involved.
Exactly. The source material emphasizes that database security is not just an IT issue. It's a shared responsibility that involves everyone within an organization. From the CEO to the newest intern, everyone has a role to play in keeping data safe.
This has been a really eye-opening conversation. It's clear that database security is not just a technical matter, it's a fundamental aspect of running a successful and responsible organization in today's data-driven world.
Absolutely. And what's fascinating is that even with all the measures we've discussed, the landscape of threats is constantly evolving. Organizations need to be adaptable, always learning and adjusting their strategies to stay ahead of the curve.
It's like running a restaurant in a city where the culinary scene is constantly changing. You need to adapt to new trends, experiment with new ingredients, and stay ahead of the competition to keep customers coming back for more. So, how do organizations stay ahead of those evolving threats in the database world? What can they do to ensure their security measures are up to the task? It seems like the key is to be proactive, not reactive. But where do you even start? The sheer number of potential threats can feel like overwhelming.
You're absolutely right. It's not about trying to eliminate every single risk. It's about understanding the most likely threats and putting measures in place to mitigate them. Your notes mention SQL injection as a common and potentially devastating attack.
Okay, remind me what that one's all about again. It sounds a bit like something out of a spy movie.
It's actually more common than you might think. Imagine a website with a simple login form. Attackers exploit vulnerabilities in the code to inject malicious SQL commands into the database query that verifies user credentials. Instead of checking for a valid username and password, the database ends up executing commands that could steal data, modify records, or even give the attacker control over the entire system.
So it's like they're hijacking the database by sneaking in their own code, disguised as legitimate requests. That's scary. What can organizations do to protect themselves from this kind of attack?
The key is input validation and sanitization. It's about treating all user input as potentially malicious and carefully filtering it before it reaches the database. It's like having a security checkpoint that inspects every package coming into a building, making sure it doesn't contain anything dangerous.
That makes sense. So it's not just about building strong walls around the database, it's about being vigilant about what's allowed through the gates. What about insider threats? We touched on those earlier. How do you even begin to address a threat that's coming from within?
Insider threats are especially challenging because they involve individuals who already have a certain level of trust and access. It's like having a rogue chef in your kitchen who knows all the recipes, can access all the ingredients, and can move around freely without raising suspicion.
It's almost like trying to predict human behavior, which is, notoriously difficult. Are there any reliable ways to mitigate this kind of risk?
It's not about predicting behavior. It's about limiting opportunities for misuse. Role-based access controls are crucial. Employees should only have access to the data and systems they need to perform their jobs, nothing more. It's like giving each chef access only to the ingredients and tools they need for their specific station.
So it's about compartmentalizing access and limiting the potential damage any one individual can cause.
Exactly. And monitoring user activity can also be helpful. Looking for unusual patterns, like someone accessing data they don't normally need or trying to download large amounts of information, can help flag potential issues.
It's like having security cameras in the kitchen, not to spy on everyone, but to keep an eye out for anything out of the ordinary. What about malware and ransomware? Those seem like constant threats in today's digital world.
They are, and the tactics are constantly evolving. Malware is like a catch-all term for any malicious software that can infect a system. From viruses to worms to Trojan horses, they can steal data, corrupt files, or even give attackers remote control over your devices.
And ransomware is like the kidnapper of the digital world, holding your data hostage until you pay a ransom.
Precisely. It encrypts your files, making them inaccessible, and demands payment in exchange for the decryption key. The source material stresses the importance of robust security software, including antivirus, anti-malware, and intrusion detection systems. It's like having a comprehensive security system for your home, with alarms, motion detectors, and strong locks on all the doors and windows.
And just like you wouldn't leave valuables lying around in plain sight, it's crucial to protect sensitive data with strong passwords, encryption, and access controls. What about data corruption? That one doesn't sound as dramatic as a malware attack, but it can still be pretty damaging, right?
Absolutely. Data corruption can occur for various reasons. Hardware failures, software bugs, even human error. Imagine a critical database file getting corrupted. It could cripple operations, leading to lost data, inaccurate reports, and a whole lot of headaches.
It's like having a key ingredient in your recipe go bad, ruining the entire dish. You might not realize it until it's too late, and then you've got a major problem on your hands.
Exactly.
Yeah.
Regular backups are crucial. It's like having a spare copy of that key ingredient in case the first one goes bad. And data validation techniques can help detect and correct errors before they cause too much damage.
So it's like having a quality control process for your data, making sure everything is accurate and consistent before it gets used. What about denial of service attacks? Those seem more about disruption than data theft.
You're right. Denial of service attacks are like a digital traffic jam, flooding a system with so much traffic that it becomes overwhelmed and unable to respond to legitimate requests.
It's like having thousands of people trying to cram into a restaurant all at once. The doors get blocked, the staff can't move, and no one can get served. It's chaos. What can organizations do to prevent these kinds of attacks?
There are various techniques, like rate limiting, which controls how many requests can come from a single source, and load balancing, which distributes traffic across multiple servers to prevent any one server from becoming overloaded.
So it's about managing the flow of traffic, making sure the system can handle the load without crashing. It sounds like there's a lot to consider when it comes to database security. It's not just about setting it and forgetting it, it's an ongoing process.
Absolutely. And as technology evolves, the threats evolve too. Organizations need to stay informed, adapt their strategies, and be prepared to respond to new challenges. It's like being a chef in a constantly changing culinary landscape. You need to experiment with new ingredients, refine your techniques, and stay ahead of the trends to keep your customers satisfied.
That's a great analogy. So if we connect this all back to you, our listener, what are the key takeaways from this deep dive into the world of databases?
Well, first and foremost, it's crucial to understand that databases are the backbone of our digital world. They power everything from online shopping to social media to critical infrastructure. And with that power comes responsibility. Protecting data is not just an IT issue, it's a business imperative that affects everyone.
It's like realizing that your favorite restaurant's success depends not just on delicious food, but also on a safe and well-managed kitchen. You might not see all the work that goes on behind the scenes, but it's essential to the overall experience.
Exactly. And just like a restaurant needs to be vigilant about food safety and hygiene, organizations need to be vigilant about data security. Understanding the potential threats, implementing appropriate safeguards, and fostering a culture of security within your organization are essential.
And remember, it's not just about preventing data breaches. It's about maintaining data integrity, ensuring business continuity, protecting intellectual property, and maintaining the trust of your customers. It's about recognizing that data is a valuable asset that deserves to be treated with care and respect.
This deep dive has given you a solid foundation, but we encourage you to keep exploring, keep learning, and keep asking questions. The world of databases is constantly evolving, with new challenges and opportunities emerging all the time.
So keep those culinary metaphors in mind. Experiment, innovate, and stay ahead of the curve to keep your data safe, secure, and ready to fuel your digital success.
Thanks for joining us on this deep dive. Until next time, happy data exploring.
See you next time.